Hi, I'm Cohen McConnell, and this is Quideo number 4. The basic question says, there are 1,785 adults are asked if they attended church in the past week. Suppose 408 said yes. Part A says, what is the mu of p hat and standard deviation of p hat? Well, the mean of p hat is simply just p hat. It's going to be 0.4, which would be the value given. The standard deviation is the square root of p hat times the difference of p hat over 1,785, which will end up giving us 0.0116. Part B says, explain why I can use the formula for standard deviation of p hat. Simply because there are just definitely more than 1,785 adults in the world. Part C says, check that you can use the normal approximation for the distribution of p hat. To find this, you're going to multiply p hat by the population and make sure that that's greater than or equal to 10, and you're going to multiply the difference of p hat times the population and make sure that's greater than or equal to 10. Part D says, find the probability that p hat takes place between 0.37 and 0.43. To find that, you're going to find the new average and subtract it by p hat over the standard deviation. And you can see that I got 2.580 and negative 2.580. And those gave me the average 0.9951, and I subtract that by the negative one, 0.0049. And that gives me 0.9902, which is the probability that p hat takes place between 0.37 and 0.43. Now we'll move on to the advanced question. The advanced question says, researchers were interested in comparing two methods for estimating tire wear. The first method used the amount of weight lost by a tire. The second method used the amount of wear in the grooves on the tire. A random sample of 16 tires was obtained. Both methods were used to estimate the total distance traveled by each tire. The table below provides the two estimates in thousands of miles for each tire. Part A says, construct and interpret a 95% confidence interval for the mean difference of U in the estimates from these two methods in the population of tires. What that tells us is we can pretty much ignore most of this graph other than the difference of scores. So by putting those values in on my calculator, I can type in stat and then go to calc and do my var stats, and that'll give me these values, which show me that my mu is 4.5503 and my standard deviation 3.2255. I need those values to construct my confidence interval, which will be my mu plus or minus my z-score, which will be times my standard deviation over the square root of my population, and that will give me my confidence interval, which I got out, as you can see here, to become 2.837 to 6.275. This means that 95% of the data of the differences of tire are between 2.837 and 6.275. Part B asks, does your interval in Part A give convincing evidence of a difference in the two methods of estimating tire wear? Justify your answer. Well, what I say is the evidence is very convincing because not only is there 95% confidence in a difference, it is 95% confident in a strong difference. As in, we aren't just positive that there is a difference that we can see. Like if there was a negative value there displayed in my confidence interval, then you could say possibly that you can't decide that one tire is better than the other. But because our value is all the way up to almost 3, then we know that there's definitely a difference in the tires. And that concludes my video.